Hello everyone, welcome to video lectures on data mining and data warehousing, Module 4 classification.
Hello everyone, let's start with the module 4, that is classification. Okay, let's see what is classification. With an example, let's discuss this concept. This is one of the data mining tasks what we have. We have already seen the data mining task, that is association analysis. This is the second data mining task, that is classification. Okay. Yes. We'll just see the definition of classification. The classification is data mining task of learning a target function that maps each attribute set X to one of the predefined class labels G. Okay, this is the formal definition. We will just see an example so that you can understand this in a better way. Yes. I'll just show you one data set. With the help of that, we will see what is that. Okay. Yes, we'll just see this data set, right? Okay, let me call this data set as training data set. So what is training data set? I'll give you one simple example. Okay. Yes, a teacher teaches a student about, say a teacher teaches a child about features of animals. Okay, so what is the teacher doing? Teacher is basically training the child about animals. So in that, again, animals, we will just take an example of dog and cat. So teacher is teaching the features of dogs and cats. So training has been given. Now the next time child, whenever looks at a creature, that is looks at a dog, looking at the dog, it has to recall now all the features that the teacher has taught about the dog, and after recalling that, so it will be able to easily classify that the creature is dog and the other creature maybe it is a cat. So it has to recall all the training things, right? So you call this as supervised learning. So here there is a supervisor or a teacher who supervises the child about all the features of a dog or a cat, right? And because of with the help of this training, child is easily able to classify the creature as dog or cat, right? So this is called right classification. So here okay, let's look at this data set now. So what is this data set basically saying? You can see here various features of animals, right? One is creatures. You can say this is body temperature, then skin color, gives birth, aquatic creature, aerial creature, has legs, hibernates. So these are all the features you can count right from name. So name is one feature, next second body temperature, third is skin cover, fourth is gives birth, fifth aquatic creature, sixth aerial creature, seventh has legs, eighth hibernates, and the last one you can see, this you call it as class label. And the class labels you can see there is the species mammals, and the rest all others like reptiles, fishes, amphibians, birds, all these let me call them as non-mammals. Mammals and non-mammals generally are the two class labels what we have in this last column. So the first 8 columns gives you the attributes of the creature, or you can call them as features. And now you can see the different records in this data set, different rows in this data set. What is it saying? It is clearly saying, see, human, name of the creature or species is human. So body temperature when it is warm-blooded, if it is warm-blooded, and skin cover is hairy skin cover, when it, one of the features gives birth, then it's not an aquatic creature, not an aerial creature, has legs, and there's no hibernation. So when all these features are true, you can call that particular species as mammals. So you can see some more records for mammals. See, 1, 2, 3, 4. Fourth record you see again. So is it the same again? The next species again, it is whale. And again, see, the body temperature is warm-blooded again. Other features you see, hair, then gives birth, aquatic creature. This is an aquatic creature and not an aerial creature. No legs, it has no legs, and then no hibernation. Still you call it as mammals. It belongs to mammal species. You can see here some more. Bat is also mammal. Then cat is mammal. And then there is some more one more species, that is mammal, right? So rest all other are non-mammals. This is a data set, you can call it as a training set. And here we will try to do the right classification based on all these features. There are n number of ways to do this classification, and here we will be discussing about one way, one technique to do the classification, and that technique you call it as decision tree induction. Okay, you have an algorithm to construct this decision tree wherein you are doing the classification based on this decision tree, and the technique to construct this decision tree, or the algorithm to construct this decision tree, here you call as Hunt's algorithm. Okay, we will just see here. Yes, this is the you can say the classification rules. Based on few rules you do the classification. We will just see all this in detail a little bit later. Okay. Yes, and now here let's come back to the definition. See here, classification is the task of learning a target. Here, what is the target there? Target is nothing but to do the classification. Target is nothing but the see, when you are shown with the creature, you should be able to clearly classify that. So target function that maps each attribute. So in order to do the classification, what are you supposed to do? Whatever you have learned, you have to recall. So you are mapping all the attributes or all the features of what you have learned, what you are been trained there. So attribute set X, all features, to one of the predefined class. So you have various class groups there. So the last column gives you the class groups. So you have learned about different animals, that is maybe creature, mammals and non-mammals class. So based on the different attributes, you should be able to map to the right predefined class label. So this is the classification definition. Okay. So now we'll move on to the next decision tree construction, right? And as I already said, you have the algorithm, and the algorithm is Hunt's algorithm, correct? Okay, so we will just see one small example of decision tree. How the decision tree is constructed, you just see here. Step by step we will see, but just you see the tree construction. So here you can see a root node. Anyways, the tree starts with the root node and ends with the leaf nodes. The leaf nodes are represented in the rectangle. Represented as rectangle. You can see mammals, non-mammals are the two class groups you have, which is represented as the leaf node here. So always the leaf node should be class label only. So you can see in the data set there are two class labels. Let's generalize this into two class labels. One is mammals and the other one is non-mammals. And you see all the internal nodes. There you have one internal node. And what is that internal node? You can see that is one of the attribute, that is the attribute there. That's the attribute there. Gives birth is one of the internal node, which is nothing but the attribute of the data set. You can see body temperature is a root node. Why this became the root node? See, you can see here in your data set, you have name as one of the attribute. Next, you have body temperature. See, with the help of name, can you classify the group into mammals or non-mammals? Can you classify the creature? No, not possible. That is why let's start with the feature here. Feature starts from body temperature. So body temperature is one of the first feature, which I will take it as a root node. To do the classification, my root node would be body temperature. And you can see the values of body temperature. It has only two values, right? One is warm-blooded, the other one is cold-blooded. Now let me call this attribute as binary attribute. Why? Because it has only two values. So I will add two branches to my root node. The left branch is telling about, yes, about the warm-blooded. This is to represent warm-blooded, and the right branch is representing the other value, that is cold-blooded. So now you can see when the body temperature of the creature is warm-blooded, and here when the body temperature of the creature is cold-blooded. Now here you see, I will add, instead of this gives birth, about this a little bit later we'll see. When the body temperature is warm-blooded, I will add one leaf node over here. Instead of this gives birth, let me add one leaf node in the rectangular box. Tell me what class I will assign here when body temperature is equal to warm-blooded. You see, when body temperature is equal to warm-blooded, can I call that creature as mammal? Yes, the first record says that it is mammal. Just to see this column as well as this last column. Forget about all these intermediate columns, okay? For this body temperature column you see, and the last column you see. See, warm-blooded, when warm-blooded body temperature is this, class label is mammal. Yes, the first record says that. Directly go to now fourth record where the class label is mammal. Fourth record, class label is mammal. See, what is the body temperature? It's again warm-blooded. Second record also, here fourth record also says that warm-blooded is mammal. Next you see, next mammal's row you come. Yes, here again. When body temperature is again warm-blooded, you see it is mammal. Again you see here, when body temperature is warm-blooded, mammal. Again you see here, when body temperature is warm-blooded, mammal, right? There are some more rows along with this, which is saying that, which are those? See here, first, second, 3, 1, 2, 3, 4, and 5. 5 rows are giving me, saying that warm-blooded creatures are mammals. But in spite of that, you can see 2 more extra warm-blooded creatures, which is that one warm-blooded creature is also classified as bird. And again here you see, one more warm-blooded creature, that is penguin, is also classified as bird, which is again not mammal, right? So that means it is here there is confusion. All warm-blooded creatures are not mammals. There are few warm-blooded creatures which are also non-mammals. So I cannot call this as pure classification. Why it is not pure classification? You see, body temperature when it is warm-blooded, if I add the leaf node here as mammals, then it would give me a wrong classification, saying that all creatures whose body temperature is warm-blooded is classified as mammals. But here we know that from the data set there are 2 creatures which are non-mammals which has the body temperature warm-blooded. So I have to further classify that. Instead of adding leaf node here itself as mammals, let me further classify this. Why? Because I'm going to make this classification as pure classification. So to do this, I will go to the next feature. The next feature is skin cover, saying skin cover I can take, or let me go to some more better attribute apart from that. See here, gives birth will clearly say me which class group it is. So you can see the creature one which gives birth are mammals. Again you see, one which gives birth are mammals. One which gives birth, 3, yes, mammals. Fourth one gives birth, yes, mammals. Yes, see here, one which gives birth, again, yes, they are one I got, that is non-mammal, and here again one which gives birth, that is mammal. So you can see, you can count here. 1 from the beginning I'll count. 1 gives birth, yes. 2 gives birth, yes. 3 gives birth, yes. 4, I got 1 which is saying that it is not mammal. So you remember that 1 record you have. So till here it is 4, and then again here 1 which gives birth. Yes, 1 which gives birth, that is the 5th record finally. That's the 5th record which is finally saying that is mammals. There are total 5 records which are saying me that one which gives birth are mammals. But there is one one among five, that is sixth one, when it is saying that it is non-mammal, that is okay, not a problem, which is better than the previous one, right? Here earlier it was saying that there are two records which are non-mammals, but here after adding this gives birth, it says me that the creatures which is giving birth, that is when gives birth is yes, I can classify that as mammals. There's only one record which is saying that one which gives birth is non-mammal. That is okay. Almost you can say 90% this. Yes, this I can call it as a pure classification. Yes, so you can see now the rightmost branch. Okay, so just see here, body temperature when it is cold-blooded. Body temperature when it is cold-blooded. One record, 1, 2, 3, 4, 5, 6, 7, 8. A total 8 records has the values cold-blooded body temperature, right? And you just see the corresponding class group directly, class label. Cold-blooded, the second and third records non-mammal. Again here non-mammals. Again here these two cold-blooded values are non-mammals. Again here these two cold-blooded creatures are non-mammals. And you can see here very clearly it says all these records, like all cold-blooded creatures are non-mammals. So this rightmost branch where the body temperature is cold-blooded, it can be classified as non-mammals. And can I call this as a pure classification? Yes, 100% this is pure classification. But whereas here it was 90% pure classification. Why? Because this contains one record which gives birth is non-mammal, right? Yes, okay, so this is how you construct a decision tree. Okay, now clearly we'll just see the algorithm to construct this decision tree. Algorithm is Hunt's algorithm. We'll just see that directly. Okay. Okay, Hunt's algorithm. So all these steps you just go through. I'll directly go to the example data set where I've taken a data set, and based on that data set the decision tree is constructed. Okay. Yes, the data set what we have taken here to construct the decision tree is this. This data set is basically saying about loan payment. Okay, so that is, see here you can see there are total 3 attributes. One is homeowner, next is marital status, and the third one is annual income. The 3 columns, the 3 attributes of a person, and the last fourth column you can see the column says that it is default borrower. So when the default borrower is equal to no, it says that these people are not risky people. That means those people have clearly paid the loan, repaid the loan. Okay, the repayment is done successfully. Next, where the default borrower class is equal to yes, those are risky people, and you call, and because these people where default borrower is equal to yes, there are total 3 records for yes, and these are risky people, those who have not paid their loan amount. Okay, you can now see homeowner clearly says that these people own a house. Next, marital status, say homeowner has only 2 values, yes or no, whether they own a house or no. Next you have marital status. 3 status, single, married, divorced. And the next one is you have annual income. Annual income is like you have continuous values, right from 60k you have 60k, 70k, 85k, 95k, so up to 220k you have here different annual income values, right? So these are binary. This I can call it as binary attribute. Why? Because you have 2 values only for this. Marital status is not a binary one, it has 3 values, single, married, divorced. And this you can call this as categorical type of attribute. The next one is continuous, all possible values you have. The last one is class group. Now let's construct the decision tree based on Hunt's algorithm for this data set. Okay, to do the classification let's use Hunt's algorithm. Yes, now As usual, the tree should contain first root node, and then we need to have a left subtree, right subtree, and then at the end we need to have the leaf nodes. Remember, always the leaf nodes in the tree should be class label only. Here we have two class label. One is default borrower is equal to no, and the other one is default borrower is equal to yes, right? So these are the non-risky people and this is risky people, right? And basically this data set is useful for officer, one who is sanctioning the loan. Whenever a person comes with the loan application, the officer has to think whether the loan can be sanctioned or not. So that his analysis is doing based on this type of data set, where he has collected already the information about previous customers who have paid the loan and one who have not paid the loan. So based on the analysis of this data set, here the officer will decide whether he can sanction the loan or not, right? Okay, now Hunt's algorithm contains first leaf node, and then also it contains internal nodes, and also it should contain the root node, right? Okay, first let's start with the leaf node itself. Which class we are going to start with? We have actually two classes, default borrower is equal to no as well as default borrower is equal to yes. Let's start with the which classification. Anyways, we want both the classes to be classified properly, but let's begin with the one particular class for which more number of records are available in the dataset. Clearly in our dataset there are more records for which class? Definitely it is no class, non-risky people. Many people have paid the loan, so that is why we have many records for default borrower is equal to no. So how many? You just count. 3, 4, 5, 6, 7 records you have for default borrower is equal to no class, and only 3 records for default borrower is equal to yes. So let's start with the leaf node, or we'll start with the class group where default borrower is equal to no. So you can see the step 1 is you have begun with the leaf node where the class label is assigned as default borrower is equal to no. This is only because here this has majority number of records. Now the next step. For doing the classification, we have to start with one of the attribute. You have 3 attributes. One is homeowner, next marital status, third one is annual income. Out of these 3, you can start with any. So let us start with the first attribute, that is homeowner. So let me start with the root node, and the root node here would be the first attribute, that is homeowner, which is binary attribute. So you can see in the second step, I've started with the root node, the homeowner attribute, and one which is binary. It has only 2 values. You can see throughout it has only 2 values, yes or no. One who owns a house and one who doesn't have a house. So homeowner is equal to yes, and when homeowner is equal to no. Now you have to add the leaf node for this particular branch, for both left as well as for right. Leaf nodes you have to assign. How to assign this leaf nodes? You just see in this data set. People who have who own the house, the first record, it says that he belongs to default borrower is equal to no class. That means what? One who owns the house has paid the loan. He is not a risky person. Again, you see, when homeowner is equal to yes, this is fourth record, homeowner is equal to yes. We are now concentrating on only homeowner is equal to yes value. So homeowner is equal to yes, default borrower is equal to no, count is 1. Next, fourth one says homeowner is equal to yes, default borrower is equal to no. The second record says again that here also it is non-risky. And directly go to the 7th value. Where is the 7th value? When yes, that is homeowner is equal to yes, default borrower is equal to no again. So that means what? All 3 records. We have only 3 records where homeowner value is equal to yes. There are 3 people only, one who owns the house, and all 3 people are non-risky people, and you can clearly say that all homeowners belongs to default borrower class equal to no. So clearly here homeowner is equal to yes. I can clearly add the leaf node as defaulted is equal to no. And can I call this as a pure classification? Yes, it is 100% pure classification, that is left subtree. Now let's go to the right subtree. What is this right? Homeowner is equal to no. See here, when homeowner is equal to no, second record is not risky. When homeowner is equal to no, he doesn't have the house. Again, not risky, paid the loan. Fifth one, when homeowner is equal to no, see here, he says that he has not paid. That means he is a risky person. I can't say that all those who don't have the house have paid the loan. Yes, so here again no. Yes, he's not risky. Again no, homeowner, he doesn't have house, homeowner equal no, but he is risky. Homeowner is equal to no, no, not risky. Homeowner is equal to no, yes, he is risky. So you can see here there are 1, 2 and 3 records says that when a person has no house, that means homeowner equal to no, he belongs to default borrower is equal to yes class. That is 3 records. Remaining records where homeowner is equal to no. So 1, 2, 3, 4. There are 4 records which says that he is not risky person or his class is default borrower is equal to no. So remember there are 4 records which says that when homeowner is equal to no, default borrower also equal to no. But there are 3 records. There are 3 records which says that when homeowner is equal to no, it belongs to default borrower class. So 4 and 3. Out of this, which is majority? Majority here is default borrower is equal to no. That means there are 4 records where default borrower is equal to, where homeowner is equal to no, belongs to default borrower class equal to no. Whereas only 3 belongs to default borrower equal yes. So majority is class no. So let me add this majority class as a leaf node for this. When homeowner is equal to no, there are 4 records, right? That is why majority class is defaulted is equal to no. So this is how you add the leaf node, one which is in majority. Okay. So here, is this clear? So homeowner, when it is equal to yes, this is the pure classification. But when it comes to right subtree, we have seen the majority, but this still contains some of the records where homeowner is equal to no, it belongs to defaulted is equal to yes. That means what? This is not a pure classification, this is impure classification, and this right subtree has to be further subdivided. The next step of the Hunt's algorithm is further classification, further division of this tree, wherein you have to select the next attribute from the data set to classify this right subtree only. Anymore no touching this left subtree. This has become the pure classification. This impure one you have to further divide or further classify. So we'll go to the next step directly, that is step C. So remember, now we are in this right subtree. Now this right one we have to subdivide. Why? Because it was impure. So how do we subdivide? How do we move further? Homeowner story is over. We'll move on to the next attribute. The next attribute is marital status. Now what is this marital status values we have? Yes, single, married and divorce we have. So 3 values. This cannot be now binary, right? So it has 3 values, but still you can convert this attribute into binary. So how do you convert this into binary? Yes. Can we club any 2 values? You can see here. Single, married and divorce we have. Just see this data set. Single, now forget about homeowner and annual income. Only marital status you focus, and you focus this last class label, default borrower. Yes, single, when he is single, he belongs to class no. Again see here, single belongs to class no. Directly go to single only. Single belongs to class yes. Single belongs to class yes. So this is not so clear, right? So because 2 single people are non-risky, 2 single are risky. So this is not so clear. So we'll go to the next one, married. Married people, non-risky, married, non-risky, married, non-risky, married, non-risky. So all married people are not risky people. They have clearly paid the loan, right? So it's a good one, good sign. So we have one married where we can purely do the classification saying that class is default borrower is equal to no. Can we go to the divorced and see? Divorced, one record says that it is yes. And then the other record says that belongs to class no. So what we will do here is we can take one classification wherein married is very pure, very clear classification. So we will add one branch for married separately, and we'll do the classification where marital status is married, the class is default borrower is equal to no. Can you see here? Marital status we have added as an attribute, and we have added to right subtree. Why? Because this was impure classification that we found here. Okay, so here marital status, and again here I'm adding one married as a separate branch, that is right subtree, and where I'm doing the clear classification saying that all married people are belonging to default borrower class is equal to no. This became now the pure classification, but this